All right. Last video I was talking about Halley's Comet. So in the last time it came, close enough so that we could see it. You could actually see it with the naked eye from the Earth, so you didn't even need a telescope. Although in 1986, it actually was not that spectacular, as it says right here. Apparently in 1910, it was very easily seen. Anyhow, it'll be back again in 2061, I think it is, or 2062. There was actually a comet back in the 1990s called Hale-Bopp. It was absolutely spectacular. You could see it in the western sky for months and months. That was actually a comet whose orbit we had no idea. We didn't even know it was coming. Its period, unlike Halley's Comet, its period was it turns out to be closer to 10,000 years. So, nobody knew it was coming. And all right, so here's an example of Halley's Comet, for example, and so this is considered a short period comet. In 2024, it'll be the farthest it gets from the sun, and then start to make its journey back towards the sun. Again, this will happen around 2061 or 2062. All right, so here it says it 2061. Very nice. So like I said, these things are relatively small, compared to planets, for example, even small compared to some asteroids. They are made mostly of, icy material, dirty icy material, and that's another thing to consider is let me go back to this picture. As Halley's Comet goes around the sun, each time it's losing material, and we think that in probably 50,000 years, or maybe a little bit more, or maybe a little less, because you don't know exactly how much material is going to come off each time that it orbits. But there just won't be enough material, and the thing will basically just disintegrate, just vaporize, and that there won't be a Halley's Comet anymore. All right, so we'll talk about this thing about what killed the dinosaurs. There is actually really, really good evidence that in the right off the Yucatan Peninsula, there's a giant crater. Here, let's see if they show it. Do they show where the crater is? No. And I thought that there's there's a crater. It's actually under the Caribbean. Most of the crater is under the Caribbean, and this we think is the impact that 65 million years ago, collided with the Earth. So it was probably a very, very rocky or metallic object, probably an asteroid, and in fact, there is what's called the iridium is a type of element that is not normally found on the Earth, but there's actually a layer all the way around the Earth, and that layer was discovered in the 1970s, and it turns out it's all around the Earth, and it's just right when the 65 million years ago, and then of course we have fossil evidence that the dinosaurs existed before the iridium layer was laid down across the surface of the Earth, and then there's no dinosaurs after that. So, there had to be some catastrophic impact all around the planet that caused the dinosaurs to become extinct. Thank goodness the little mammals that were around at the time did not go extinct. So that that was very fortunate for us. All right, so this is another mission that went, in this particular case, went through the tail of a comet. There was actually a mission that went through the tail of Halley's Comet back in the 80s. It was what was the name of that? I can't remember the name of that particular mission. It wasn't NASA that did it. It was the European Space Agency. But anyhow, this particular mission actually caught some of the material, these dust particles in basically little aerosol, aerogel. It's basically little silicon wafers that caught this stuff, and this thing actually, the Stardust mission flew back to Earth after it went through and captured some of the dust. Unfortunately, it actually crashed into the desert of Utah, and but some of the material was recovered, but certainly not all the material that we were hoping for. There were other missions. This is the mission Deep Impact, which basically slammed into a comet to try to understand the composition of the comet, in better detail. All right, so now where do the comets come from? So comets like Halley's Comet tend to exist within what's called the Kuiper Belt. The Kuiper Belt is outside of the orbit of Neptune. So these, including Pluto, we'll talk more about that in just a little bit. So these are what are called trans-Neptunian objects, so things that are beyond the orbit of Neptune, but they still align with the orbit of all the planets, the plane of all the planets. However, much further out than the Kuiper Belt, there is a region that surrounds the entire solar system, and it was proposed. I think this guy Oort lived in the 1950s, and so it's called the Oort cloud. This is a proposed region. I want everybody to understand that. The Kuiper Belt, we've actually observed objects in the Kuiper Belt. In fact, we just recently sent the New Horizons spacecraft after it had visited Pluto. It visited another object in the Kuiper Belt, and it's actually got a name. It's called Ultima Thule. It was actually very recently. The New Horizons spacecraft took pictures of it, and actually that's the most distant object in the solar system that was visited close up by a spacecraft sent from the Earth. Anyhow, surrounding the entire solar system in 3 dimensions is a spherical region where we think the comets come from. The reason that Oort proposed this is actually a really good reason, because comets don't always come towards the sun in a nice plane with like, for example, within the plane of the solar system. Some of them come at huge angles, like 90 degrees with respect to the sun, like this orbit right here, or very close to 90 degrees. And so Oort proposed that there was this region of icy bodies, very, very far from the sun, and we don't know exactly how far this region goes. It could go out 100,000 astronomical units for all we know. And like I said, this is a proposed region. Nobody's actually observed anything from that. These things they're way too small for our current telescopes to see. However, like objects in the Kuiper Belt, like obviously Pluto, and there's another object called Eris, and another one called Sedna that we've observed. And of course now, we've sent a spacecraft to Ultima Thule. All right, so Pluto was discovered in 1930 by a guy named Clyde Tombaugh. The reason that people looked for Pluto is they saw irregularities in the orbit of the orbits of Uranus and Neptune that told them that there was another large object out there. Now Pluto's not that big, but it was big enough to influence Neptune and to some extent Uranus. Actually, Pluto crosses the orbit of Neptune, as you'll see, when it gets closer to the Sun. Its closest approach to the Sun, it actually gets a little closer to the Sun than Neptune is. All right, so we'll see that. Here it is right here. So the last time it did this was from the years 1979 through 1999. Pluto was technically closer to the Sun than Neptune was. Anyhow, that is. A lot of people often ask me, will these two collide someday? And the answer is no. They're actually not in the same plane. It turns out Pluto's orbit is very tilted with respect to the Sun, and so they won't crash into each other. Pluto has actually three relatively large moons. Well, Charon is the largest of the moons, and that was discovered first. Nix and Hydra were discovered a little bit later. There's a nice, relatively good picture of it. We have actually much better pictures from the New Horizons spacecraft that visited Pluto in the, what was it? I think in 2015 or 2014, something like that. Anyhow, we have really good images, not telescopic images, but images of a spacecraft traveling by these objects. There's the orbit of Charon. All right, so talking about the Kuiper Belt, it's actually when this slide was created, they probably didn't define it. This says this is incorrect. It's actually outside of the orbit of Neptune. All objects outside the orbit of Neptune, roughly within the plane of the solar system, are considered the Kuiper Belt. So that's a region of the solar system. All right. So Pluto actually turns out to be a little larger than an object, another Kuiper Belt object called Eris. All right. So Eris, this object right here, which actually has its own moon, was discovered in the early 2000s, and at first calculation actually showed that Eris was a little bit bigger than Pluto. It turns out that that's not true now. We've refined our measurements, and it turns out Eris is actually a little smaller, just slightly smaller than Pluto. But that caused the astronomical community to say, well, is Eris the 10th planet? Is that what we should be calling it? And here's some pictures right here of comparing the size of I'll get back to that in just a second. There's the size of the Earth. There's the Earth's moon. Pluto, of course, is smaller than the Earth's moon. There's Eris. There's some other objects out there. Sedna is one of the most distant objects within the Kuiper Belt that we know of. All right, so here's getting back to the story of Pluto. So, like I said, when Eris was discovered in the early 2000s, I think it was around 2003 or 2002, people realized that we had to do something. Like there had to be either a 10th planet added, or what actually turned out to happen is the astronomical community, the IAU, got together in 2006 and basically voted. And the vote was, first of all, to define what it means to be a planet. So, certainly Pluto orbits the Sun, so, this condition 1 is met. It has to be massive enough to be spherical. That condition is met. But the thing is, the thing that's not met is it doesn't clear out the orbit. It doesn't clear out all the